Now, we're going to talk a little bit about the Atwood machine. An Atwood machine is a setup like this. So you have a pulley that we consider massless, meaning like the mass is negligible. And later when we do a rotation, we'll consider the mass of the pulley. And you're going to have two weights, two masses, hanging on each side. And this is going to start to accelerate, and we're going to try to find the acceleration of the system. And we'll try to find the tension in the rope. Okay? So I know this is in the way, so let me just get it out of the way, and so we can continue. Okay? Right. So I'm going to show you a derivation of acceleration and tension. So I have a system like this. So I'm going to put A on the left all the time. So let's just say B is heavier. So the system is going clockwise. Now I'm going to make a list of the forces acting on each one of these bodies. Now if the system is going clockwise, for A up is positive. For B, down is positive. I can change that. For A, you're going to have tension. Since it's accelerating up, the tension here has to be bigger than the weight of A. And you have to show that. The tension here is the same as the tension on the other side. So I'm just going to call it T. But since this B is accelerating down, the weight of it is going to be greater than T. And we're going to consider this whole thing, the two masses, as the system, which makes the T's, the tension, internal to the system. So I'm going to do F net equals MA. So WB wants to make me accelerate, and WA wants to hold me back. And I'm trying to accelerate both masses, MA and MB. Okay? So this is MB times G. This is MA times G. So if you develop that, you should get MB minus MA over MA plus MB times G. Now, this is just for you to use as a shortcut if you have a multiple choice question. But if it's open-ended, you have to show the work. And we're going to do that in class with one of the problems. So basically the pattern is like you take the difference of the two masses, divide by the sum of the two masses, times 10, if you're on Earth. Now let's do another expression for tension in terms of the masses and G. So I'm going to pick just one of the objects. So let's just say I pick B as the system. So I'm going to do F net equals MA, but just for B. So WB wants to accelerate it, T wants to hold it back, equals the mass of B times the acceleration. So this is MB G minus tension equals MB which makes the tension equals MB G minus A. I hope you can see that. So I move this over there, I move this over here. So T is MB times G minus the expression I found earlier. G. Okay? So I can take out a G. Okay, so it's going to be MB, G, and I'm left with 1 minus MB minus MA over MA plus MB. And if you do a common denominator, you should end up with T equals 2 MA MB over the sum times G. Now the masses here, actually the masses in here, doesn't matter. They can be in grams, kilograms, pounds, it doesn't matter. Down here for tension, it must be in kilograms. Because you have the mass here twice, but you only have the the unit for mass twice, but here you only have it once. So you have to put the unit in kilogram. Okay, so let's take a look at an Atwood machine on a flat surface. What we call that a modified Atwood machine. Now again, these expressions are just shortcuts. So if you want to find the tension, multiply the two masses in kilograms times 2 times 10 if you are on Earth, divided by the sun. And you're done. If it's open-ended, you have to show the work. Now let's look at this other type of machines, of a commodified machine. So you have a string here, you have a mass hanging, and we're going to do this with friction. Now, if you're looking on HICO in the answer key, I gave you an expression for A and an expression for T in terms of the masses in G and coefficient of friction. So maybe this is attached there, something like that. So I'm going to put B hanging and A on the table. So B, you're going to have WB going this way. T is going to be smaller because you're accelerating down that way. This is the tension, same tension pulling A. You also have the weight of A. You have the normal force on A. Now the normal force and the WA should be equal because those are the only two forces acting vertically. And let's just say there is some friction. Okay. And I'm going to try to do a problem with this. Yeah, let's do that instead of just talking about it. Okay. So this is 25 kilograms. This one is 10 kilograms. Okay. And B doesn't always have to be heavier than A. You can have B smaller, and you want to accelerate a heavier object. You remember the first lab we did in this unit when we proved the law of inertia, Newton's first law. So here we go. So we're going to consider both of this as the system. Actually, I want to do one where there is friction. Yeah, I'm going to do part B. Part A is easy. So WB wants to accelerate you. The tensions are internal. Friction wants to hold you back. This friction, right? This does not hold you back. This does not hold you back. It's the friction that holds you back. Okay? It's opposing the motion. Equals the two masses times A. Well, WB is just 250 minus. Now, FF is mu Fn, and the mu is 0.6. Now, the Fn is the same as WA. So WA is 10 times 10 from W equals mg. So that's 100 equals the two masses is 25 and 10 is 35A. So A equals, I'm going to look at the answer here. It looks like it's 5.43. Okay. Now, if I want to find the tension, I just pick one of the two. It doesn't really matter actually. So I'm going to pick B. Okay. For B, it's going to say WB minus tension equals the mass of B times the acceleration. This is with friction, which means WB is 250 because it's 25 times 10 minus the tension. The mass of B is 25 times the acceleration, which is 5.43. Then you get a tension that's equal to 114.29 newtons. It's as simple as that. They're all the same. It just sometimes he asks you to find what do you call it? Sometimes he asks you to find the acceleration, sometimes the tension, sometimes the mass. And I think that's it for that. Okay? So I hope this video was helpful. Now just remember, when you're dealing with acceleration, the masses could be in grams because you're going to have mass here. You should have mass here. You should have a mass here. Okay? for the tension, they have to be in kilograms. Okay. And because you don't have a mass here. Okay. So I think that's it. All right. So this video is going to be called Atwood machines. Okay. Thank you.